Hello and welcome to Amazon Redshift beginner course. I'm so happy that you have decided and taken first step to learn Amazon Redshift. In this course, we'll start from the basics. We'll talk about the core architecture and salient features. Moreover, we'll discuss about important topics like distribution style and sort keys to consider while learning or working on Redshift. Since this is a beginner course, I have not included any labs. However, there will be quizzes at the end of each module. This will further strengthen your knowledge and understanding at every step. If you are ready, I request you to meet me in the next lesson. Thank you. Hello and welcome to the new lesson. If you are an absolute beginner on Amazon Redshift, then this course will give you a good overview about salient features in Amazon Redshift. The goal is that after taking this course, you should be comfortable in talking about Redshift. You should be able to participate in group discussions at your workplace. Also, understand solutions concerning Amazon Redshift. We'll start with the fundamentals of data warehouse, MPP system, and Columnar database. Then, we'll also see how these fundamentals are applicable to Amazon Redshift. We'll see how parallelism is built as part of the core architecture in Redshift. After that, we'll talk about the distribution style and sort keys, the two very important topics which every beginner in Amazon Redshift should be aware of. So if you are ready, let's move to the next module and I'll see you there. Hello again. This is the first lesson in this module and we are talking about data warehouse. If you Google data warehouse, you can find a lot of different definitions. It's subject oriented, time variant, non-volatile, integrated. Somebody will classify in a different format, and all this information may become overwhelming for a beginner. So what I want you to do is just remember this image. I don't want you to mug up the definition of data warehouse. As a beginner, I want you to understand what is the concept behind data warehouse, and I'll try to rephrase it in my own words. A data warehouse is a system that allows users to complete three main tasks. First, mechanism to gather data from various sources. Second, provide tools to transform data and apply business logic on it. Third, enable business to take decisions by supporting reports and visualizations. If you see this image, there are multiple sources which are sending data into data warehouse. Now a data warehouse should provide a mechanism to load this data into tables. Secondly, it should also provide a mechanism to transform that data by applying business logic on it. Most of the time, SQL is used for transforming the data. However, to make things simple, there are ETL tools available in the market which gives a good UI where you can drag and drop and implement the same transformations without writing any SQL code. And last, once you have the process data, you can share it downstream with some other applications for further analysis or maybe reporting and visualization to enable business to take decisions. So I want you to remember just three characteristics for data warehouse. So whenever you think about data warehouse, I want you to think that, okay, it's a system that allows you to gather data from various sources. You can apply business transformations on that data and make it more meaningful. And once you have that process data, you can give it to the downstream applications for reporting, visualization, or further analysis that can enable business to take decisions. So as a beginner, I think this information should be sufficient. This video is not a dive deep into a data warehouse, so I will not further discuss about data warehouse. Welcome to the new lesson. In this lesson, we'll talk about massively parallel processing, or in short, MPP system. To explain MPP system, we'll see an example where a new project has come to the director of a company. The director has multiple managers reporting to him. What director will do is, he will split the project into smaller projects and will give those smaller projects to each manager. Manager has their own team of developers who will work on those small projects. As and when those small projects are completed by individual manager team, they will report it back to the director. The director will collate the information from all the managers and then will consolidate it to give a final picture of the project. Similarly, in MPP system, there is a node. For sake of simplicity, we can assume node is nothing but a computer machine that has storage and that has a compute. So it can process some information and it can store some information. So in a distributed environment, we have a multi-node cluster where one single node will act as a director or the main node. In different RDBMS, we give it a different name. So there is a main node that will take the request from the user. It will split it into multiple smaller and similar tasks, and then it will delegate that task to other nodes which are reporting to that main node. Each node will have its own set of compute and storage capability. So each node will work on that task, will do its own work, and then once the work is complete, will give the reply back to the main node. The main node coordinates among different nodes reporting to it. It will collect the information and then it will collate it into a single output and will share it with the user. So it works in the divide and conquer approach, where a single task is divided into multiple smaller tasks. Each task is completed individually by different nodes. Once all the nodes complete their task, they give the result back to the main node collates and give it back to the user. In comparison to SMP, where there is no parallelism and the entire work is done by a single task, here we can see that a same task is split into multiple smaller tasks and parallelly multiple nodes can work on it. So this parallelism increases efficiency of the system significantly. I just want you to remember, whenever you hear about MPP, you should remember this image that okay, there are three characteristics of an MPP system. It divides the work into smaller and similar tasks. Second, the individual teams will be working in silo to complete their respective tasks. And once all the individual teams complete their tasks, they report it back to the main node, and the main node collates that information into a single output. If you can understand this, then you know at the high level what is MPP system. I think as a beginner, this information should be sufficient. So if you are ready, let's move to the next lesson where we'll talk about Columnar database. Hi, welcome to the new lesson. In this lesson, we'll talk about Columnar database. Columnar database is a data storage strategy where the values or the information is stored on the basis of columns and not on the basis of rows. I'll explain it with the help of a simple example. So say I have an employee table and there are three columns in the employee table: employee name, employee city, and employee age. So all the rows are stored in a storage block. I'm talking about physical storage of the data in the disk. So in this case, what will happen? The first row will be stored in first storage block. The second row will be stored in the second storage block, and third row is stored in the third storage block. So this is how in a row oriented database, information is stored in the storage. Now coming to columnar, if you see, there is a difference. All the column values are stored together. So if you see here the employee name, all the employee name values are stored together in the storage block. Similarly, in the next storage block, I will see that the second column is stored together. Column 3 is stored together in another storage block. So you can see that what is the difference between a row oriented database storage and a column oriented database storage. In row oriented database storage, all the columns present in a single row are stored together. So this is one row, this is row 2, and this is row 3. In column oriented database storage, all the column values are stored together. So this is column 1, this is column 2, and column 3. So all the columns are stored in same or the adjacent blocks. Now why this is good? In any analytical processing, we don't read all the columns present in the table. We select few columns. Now say if I'm running a query where I just need employee name from the employee table. So I'll read storage block 1 to read the value of row 1. Then I'll read storage block 2 to read the value of row 2. Then I'll read storage block 3 to read the value of third row. To fetch the employee name, I have to go through 3 storage blocks to retrieve the value of employee name for all the rows. Similarly, if I have to run the same query on the column oriented database storage, I will just read one storage block. Because for the column employee name, all the values are stored together in the same storage block. So in this case, you can clearly see I'm just reading one storage block, whereas in this case, I'm reading 3 storage blocks to get the value of employee name for this table. Since I'm reading just one storage block, the overall turnaround time and the IO required will be significantly less. So this is very efficient read when few columns are required. Also, since I am storing the information for each column together, I can apply better compression algorithm at the storage level. So in this case, if I have to apply some compression, my storage block has string values and a numeric value, both combined into the same storage block. So having a compression algorithm which can be optimized for a string as well as numeric values slightly complex and may not be that efficient when compared to applying compression on a storage block which holds only string value or which stores only numeric values. So the compression is way better in columnar database storage compared to row oriented database storage. So to conclude, the columnar database is a strategy of storing data where all the values in the column are stored in the same or the adjacent blocks. This results in efficient read when few columns are required. You don't have to go through all storage blocks. You can just read one or two storage blocks depending on where your data is stored. And it also allows you to apply a better compression algorithm to reduce the IO required to process the same data. So I think as a beginner, this information should be sufficient, and that this closes our fundamental chapters. In the next lesson, we'll see how these three fundamental concepts of data warehouse, MPP system and columnar database are applicable to Amazon Redshift. You are doing great. Let's meet in the next lesson. Hi there. Welcome to the new module. In this module, we'll talk about how the three fundamentals of data warehouse, MPP system and columnar database are applicable to Amazon Redshift. So let's begin with our very first lesson of this module. We'll talk about Amazon Redshift, the data warehouse. So if you can recall, for any data warehouse, as a beginner, I asked you to remember just 3 points. That a data warehouse should allow you to gather data from various sources. It should give you tools to run your business transformations on that data. And then once the data is processed, it should enable you to share it with downstream applications so that the business can take some decisions on that. Now coming back to Amazon Redshift, we'll talk about those three fundamental concepts and then we'll see how each concept is applicable to Amazon Redshift. So let's begin with this lesson where we'll talk about how Amazon Redshift is considered as one of the leading cloud data warehouse in the market today. The very first point for any data warehouse is it should let you gather data from various sources. The most common way of loading data into Amazon Redshift is get the data into the S3 bucket and from there run the copy command. For those beginners who does not know what is S3, S3 is nothing but a storage space which is available in Amazon Web Services. Say if you have used Google Drive or Dropbox, these are just the services that provides you storage space. Similarly, in AWS environment, S3 is the service that lets you use storage space as per your requirement. So the most common way of bringing data into Redshift table I have seen so far is you get the data into an S3 bucket and then you run the copy command to load that data from S3 bucket into your Redshift table. The second method is if there is a source that supports JDBC connection, you can create a JDBC connectivity, connect to the source and pull the data from the source into your Redshift table. Recently, there was a feature launched where if the source also has Amazon Redshift on their end, then you don't have to export the data and bring it into S3. You can directly use Amazon Data Share feature, which will allow you to bring data from cross-account Redshift cluster as well. This is something which I am seeing gaining popularity in recent times. Also, like other AWS services, Glue, Lambda or Amazon EMR, you can process the data by different methods and then load the processed data into Redshift tables. Also, if you have a data lake using lake formation, you can read that data by creating an external table in Redshift and pointing resource link to those lake formation tables. I'm not diving deep into these topics, but as part of this course, which is for absolute beginners, I think at the high level, if you understand that there are multiple ways by which you can bring data into Amazon Redshift tables, it should be fine. The next point for a data warehouse is it should allow you to run business transformations on top of the data. As I mentioned earlier, SQL is probably the most common way of transforming data in any data warehouse environment. So Amazon Redshift let you run SQL commands on the data stored in the tables and you can apply your business logic in the SQL code. Also, another trend what I have seen is the other AWS services like AWS Glue or Amazon EMR, enterprises generally run a Spark applications on top of the data. They process the data and then they push the processed data into Redshift table. The third very common way I have seen is if your enterprise already has a ETL tool like Informatica, they can connect to Redshift and they can use ETL tools with the UI to drag and drop and create transformations that will process the data and load it into Redshift tables. Let's move to the third point, which is enable business to take decisions. Once there is a process data in the Redshift, what I have seen is you can unload the data into S3 bucket and then you can share it with the downstream applications. QuickSight and other reporting tools can also connect to Redshift for visualization purpose. These dashboards created in a visualization tool are referred by the end business users to take some critical decisions supporting their business. You can also share the data in your Redshift cluster with another downstream application if that application also use Redshift via data share. So in the first point, you were the consumer of the data when the source also has the Redshift cluster. In the third point, you become the producer of the data when the consumer also has the data share. So with data share, you can get the data from another team, and with data share, you can also give the data to another team, provided that both the parties, the source and target, have Redshift cluster in place. So now you can clearly see that Amazon Redshift is a cloud data warehouse that lets you gather data from various sources. It helps you in applying business transformations and process the data as per the requirement. It also enables business to take decision. If this is clear to you, let's move on to the next lesson where we'll talk about how Amazon Redshift is an MPP system or a massively parallel processing system. We'll also talk about Amazon Redshift core architecture. We'll also see how parallelism is built as part of the core architecture of Amazon Redshift. So if you are ready, let's move to the next lesson. Hello and welcome to the next lesson. So in this lesson, we'll see why Amazon Redshift is considered as an MPP system and how parallelism is built as part of the core architecture. There are basically two types of nodes in Amazon Redshift. One is the leader node, which communicates with the end user, and the other are the compute nodes. There is a third type of node also available, which is called spectrum node, but we'll not get into that as part of this beginner's course. When the end user submits a request to leader node, the leader node will break the task into smaller and similar tasks. These small tasks are passed to compute nodes for processing. These compute nodes have their own memory and storage space to complete the task. The compute nodes are divided into slices, which are like mini computers that actually process the data. The compute node has at least one slice depending on the node type in the Redshift cluster. Once the task is complete, the compute nodes sends the processed data back to the leader nodes. The leader node will collate it and will send the output to the end users. So you can see Amazon Redshift architecture is built in a way where any given task to the leader node will be divided into multiple smaller tasks. All these compute nodes will work in parallel. So parallelism is built as part of a core architecture of Amazon Redshift. Once the compute nodes finish their task, they give the result back to the leader node, which will collate all these smaller results into a single output and will share it back with the end user. So I hope this is clear to you. If you are ready, let's move to the next lesson where we'll talk about how Amazon Redshift works as a columnar database. From the previous lesson, we are clear that what is a columnar database. In this lesson, we'll see how the columnar database is applicable to Amazon Redshift. So we know that in a columnar database, whatever the rows are there in the table, each column are stored in the same or adjacent data blocks. To further increase the efficiency of a columnar database, Redshift has storage blocks of 1 MB size. This is considerably a bigger size compared to other RDBMS where typically it ranges from 2 KB to 64 KB. The advantage of having a bigger storage block size of 1 MB is you can accommodate more values into the same storage block. Compare it with the 128 KB storage block where you may require multiple storage blocks to store same information which you can store in a single storage block of 1 MB. Also, since it's a columnar database, the column data types are same which are stored together. So here in this case, say this is the third storage block which stores all the numeric values. Now depending on the numeric values, you can choose which compression algorithm is best for numeric values. Similarly for these, you can choose which compression algorithm is best for string values. Depending on the encoding algorithm you will use, you can save a lot of space and also reduce I/O drastically. That will further enhance the performance of your queries. Some of the common encoding algorithms available in Amazon Redshift are AZ64, LZO, ZSTD. So you can see that Amazon Redshift is a columnar database and some tuning have been done to make it a very efficient columnar database, like increasing the storage block to 1 MB size each and coming up with more advanced and tuned encoding algorithm or compression algorithm which are specific to data types, which can result in better storage space, higher compression and better efficiency by reducing the I/O. Now I believe all the 3 points are clear to you. So we have seen how Amazon Redshift acts as a data warehouse, how it works as a MPP system, and how it has optimized the columnar database. If this is clear to you, let's move to the next module where I'll talk about distribution styles and sort keys. As a beginner, at least theoretically, you should know what is a distribution style and sort keys in Amazon Redshift. So whenever you are ready, let's see you in the next lesson. Hello and welcome to the final module of this course. You are doing great so far. In this module, we'll talk about the distribution style and sort keys in Amazon Redshift. These two are very important topics, and as a beginner, you should be aware what is distribution style and what are sort keys in Amazon Redshift. So in the first lesson of this module, we'll talk about distribution style. We all know that Amazon Redshift is a columnar database. There is a standard manner in which how table data is stored into the storage blocks is determined, and that is nothing but the distribution style. So depending on the distribution style of the table, Amazon Redshift decides how the data will be stored in the storage blocks. There are 4 different types of distribution styles available in Amazon Redshift. The first is key, the second is all, the third is even, and fourth is auto. So let's start with what is a distribution key style. So in a distribution key style, the user will define a column in the table as the distribution key. The column values will go through a hashing algorithm and then it will be determined which slice will hold that row. So since it's a distributed system, one row may go to slice 1, the other row may go to slice 2, and the third row may go to slice 3. Which slice will hold which rows is determined using the distribution style. User has to select a single column which will be acting as a distribution key. So say you have a Redshift cluster where you have 3 slices. Slices are nothing but a part of a compute nodes. So let's understand this with an example. For this employee table, there are 3 columns. The user has determined that okay, I'll make distribution style key for this table, and the key will be the employee name column. So what will happen when the Redshift will encounter this first row value as Mark, it will go through an hashing algorithm and it will be determined that Mark will go into the slice 3. Similarly, the second row when the Louis will come, again it will go through the same algorithm and it will be determined that this row will go into slice 1. Similarly, row 3 will come, it will go through the same hashing algorithm and it will be determined by Amazon Redshift that I will store this row in slice 2. When the fourth row will come, again it will go through the same hashing algorithm and say it got the slice 2 for this also. When there are 4 rows in the table, we see that depending on the employee name as the key column, some hashing algorithm was used depending on the key value, and then Amazon Redshift will determine that okay, this row will go into this slice, this row will go into this slice, and these 2 rows will go into this slice. So now you can see all the slices hold some portion of the table, but how it determines which portion will go into which slice, that is using the key column, which is nothing but employee name in this case. If this is clear, we'll move to the next distribution style, which is all. In all, what happens, each slice will store the entire table. All the 4 rows will go into slice 1, slice 2 and slice 3. So you have to be very careful when you are using distribution style all, because if you do it for a very large table, all the slices will hold the entire table, which will result in high consumption of storage space. Hence, it is not recommended for big tables. For even, what will happen? Amazon Redshift will simply distribute the rows among the slice in a round robin manner. So you see, first row will go to slice 1, second row will go to slice 2, third row will go to slice 3, again fourth row will go to slice 1. If there are more rows, 1, 1, 1, 1, 1, 1, like that, Amazon Redshift will continue to add the new rows across the slices. The advantage is with even, as the name suggests, it is safe to assume that all the slices will hold roughly the same amount of rows. With all the slices will have all number of rows. With key, depending on the value you have supplied for the key column, the slices will be determined. So if you choose a key for which the values are not very unique, in that case, you may end up having one slice having more rows while other slices may be empty. For example, if we have a gender column also here in this table, employee gender, and say it has just two values, male and female, and you choose gender column as the key column. In that case, what will happen? When the male will come, it will go through the hashing algorithm, and say Amazon Redshift determines that it will go to slice 1. And when the female value will come, it goes through the hashing algorithm, and say Amazon Redshift determines that it will go to slice 2. But what will happen to slice 3? So in that case, what will happen? The entire table will be split into slice 1 and slice 2, and slice 3 will not have any data for this employee table. This results in skewness. As part of this beginner course, I will not be diving deep into what is skewness and how we can fix it. But as the beginner, you should understand that there are several distribution styles available in Amazon Redshift. And when you are picking the key one, you have to be careful that whatever column you pick as the distribution style key should have unique values in it. Else, it may result in skewness that will impact performance very badly. If these three styles are clear to you, there's a fourth distribution style also available in Amazon Redshift, which is called as auto. So auto means that you let Amazon Redshift determine what should be the best distribution style for this table. But in that case, it will only toggle between all and even. So if the table is very small, auto will go for the all approach. If the table grows in size, it may switch from all to even. But if you know your data, I will recommend not to go with the auto. You can select either key, either all or even, and you should try to build some understanding of the table. So if these four distribution styles are clear to you, let's move to the next slide. So in the first example, we are explaining how we can use a distribution style key in Amazon Redshift. This is the basic create table statement for this table employee, where it has three columns. You see I have specified employee name as the dist key, and at the end I have specified this style key. It means that this table distribution style is key and the distribution key column is employee name. Similarly for all, you can see here I have mentioned this style as all. So in this case, if I create a table like this, any row which I insert into this table will be moved to all slices. So if table has 100 rows, all 100 rows are available in all the slices in the cluster. For even distribution style, I have to use the keyword even in my table definition. So if distribution style is clear to you, let's move to the next lesson where we'll talk about sort keys. Welcome to the new lesson. In this lesson, we'll talk about sort keys in Amazon Redshift. So if you have a database background, you should be aware about partitions. In Amazon Redshift, we don't have any partitions. Something which is somewhat similar to partitions in other database is sort key in Amazon Redshift. So what exactly is a sort key? In your table definition, you can specify one or more columns as a sort key column. What will happen? The Amazon Redshift will try to store the data in the sorted order as per mentioned in the sort key column list. So here in this case, you can see I have specified date column as the sort key. So whenever I am loading a data into a table, you see that it is sorted on the basis of date. Whenever a new data is added, it is added in the sorted order of the date. So all the data for July month is together, all the data for August month is together, and all the data for September month is together. So how sort key helps in improving the performance is, whenever there is a sort key in the table and the table data is sorted in a proper manner, whenever you run a query, say in this case, if you want to run a query for the month of August, Redshift will directly come to this place and will scan rows from here till here, because it knows that the data stored in the storage blocks is in a sorted order. Anything above this is for the month of July and anything below this is month of September. So everything in between is month of August. So it will not scan these rows. It will just scan these rows which belong to August month, thereby avoiding the full table scan. There are two types of sort keys available in Amazon Redshift. One is compound sort keys, which is the default. So in this, the sorted order of row is determined in the same order as it is defined in the table definition. So in sort key, like unlike distribution key where you can just have one column as a dist key, in sort keys you can have multiple columns listed as part of a sort key. In compound sort keys, the sorted order of row is determined in the same order as it is defined in the table definition. First column gets the highest priority, then second, and so on. So if in this case I would have mentioned date and customer ID both as a part of a sort key, the sorting order will respect the date column first and then the customer ID. It is similar to SQL order by command where you specify order by and multiple column list, and the ordering is respected by first column first and then second. In case there are multiple rows with the same value for the first column, then the second column will determine what will be the order of the output. Similarly, Redshift sort key also applies the same logic. If the value for the first column is same, then it looks for the second column for the ordering of data while storing. The second type of sort key available in Amazon Redshift is the interleaved sort keys. In this case, all the columns in the sort key definition are given equal priority. This definitely adds operational and maintenance overhead for the table. It's quite expensive operation to maintain this. Hence, it is recommended to use only when it is really required and you understand your data. So I hope the sort key concept is also clear to you. Distribution style basically tells you how data is stored, and sort key tells you that when the data is stored, what should be the order of storing it. Which row should be stored first, which row should be stored below. So this brings us to the end of this module. I have covered all the important topics which I feel is required for a beginner for Amazon Redshift. I hope all these topics are clear to you now. Hi there. We have reached the end of this Amazon Redshift Absolute Beginner course. I'm so proud of you for completing this course. I hope this course must have given you a good insight into the Amazon Redshift, its salient features and important topics. As a next step, I'll propose you to dive deep into all these topics one by one. You may also reach out to me for one-to-one coaching on Amazon Redshift. Again, I wish that you learn about Amazon Redshift smoothly. If you have any comments or feedback regarding this course, let me know in the comment box below. Thank you and have a happy learning.